Okay. Awatif, are you able to look at my slide already?
Yes, Doctor.
Okay, great. All right. So we'll just continue. Okay, I think sometimes I forgot to share some of the slide. For example, chapter 4 and today, by today lah, I should be able to share chapter 5 slide, which I should have provided all the solution for all those activities I have asked you to try out, because it's straightforward, these activities. I want you to try it out on your own, and I'll provide the solution, because actually our class is 2 hours, and I actually allow 1 hour for you to try on all those exercises, all right, or activities. Now, today we'll be focusing on energy dissipated structure. Now, these energy dissipated structures is commonly built at the toe of a spillway to reduce kinetic energy of flow. Now, when flow out from spillway gate, right, it actually flows very fast. Okay, it could be as fast as the speed of our car on highways, all right, um, or even more, all right. So, how are we going to reduce this high energy flow, or basically the high energy? So, and of course, this high energy flow would actually erode or scour the toe of the spillway. So therefore, we need to build a stealing basin. The name stealing basin, it kind of want to steal, make the water flow still, become still, all right? Try to reduce the energy. Therefore, we have this stealing basin structure at the toe of stealing basin. It's actually the purpose is to reduce the kinetic energy of the flow, as well as to try to reduce or avoid erosion lah, basically. Now, there are a lot of types of sealing basin. Uh, One type is actually, well, there is a set, all right, proposed by USBR. USBR actually is the acronym for United States of Bureau of Reclamation. All right. If you Google USBR, you should be able to find the full, and also you can look up the what is the agency profile is about. It's more on soil reclamation and things like that. All right. It's actually is including construction of dam, reservoir, um, a lot more. A lot more of the function of USBR lah, basically. Now, our chapter will focus only on the design of one type of stealing basin, which is stealing basin type 3 in the USBR design. All right. So therefore, it's USBR stealing basin type 3 that we are going to focus on. Now, this stealing basin type 3 is very stable. All right. It is recommended for discharges up to 18.58 meters squared over second. All right, with velocity, all right, between 15 to 18.3 meters over second. Now, this velocity, right, if you equate it to kilometer per hour, is about 55 to 60 or 70 kilometer per hour. It's quite fast, all right. It's quite fast. So at least you have an idea, right, about how fast the flow is. All right. This is the average, right? 14.5 to 17 Prit number. All right. It could be high. There are stealing basin type. There are different type of stealing basin that can accommodate higher flow. All right. Now let's take a look at, the set of USBR sealing basin. It ranges from type 1 to up to, I believe it's type 9 or more than or 10, all right? Okay, you have all those type here. Of course, the different type cater for different fruit number, velocity, and the design of reservoir itself. Okay. So if you look at this, sealing basin type 3 is quite simple, alright? They don't have these tube blocks, alright? The end seal, buffer block piers, alright? So at the bottom there, you can basically see the sealing basin type 2. And then type 3, this is what we are going to design. Same basin type 3, we have the tube blocks, buffer piers, as well as the end seal. The flow is coming down from our left towards the right. Okay, then you have sealing basin type 4, and then sealing basin type 5, 6. All right, you can see the different design is actually to cater for the needs for different needs 7, 8, 9, 10. All right, there are 10 sealing basin. Actually, USBR has more types of sealing basin. I'm just actually showing you 10 types. All right, they have a lot more. You can actually, it's available when you Google it. It's available at the website of USBR. A lot of types of sealing basin, right, that cater for the needs. All right. Now, this is the USBR sealing basin type 3. You see that I've highlighted, right? This one is, sorry, just a second. I'm going to present also. Now, this set is known as the chute blocks. All right, you have a lot of blocks here, chute blocks. Now, sometimes, all right, to make our life easier lah, all right, we'll just call it as blocks, a set of block A, all right, blocks A. So we'll call it as block A, block B, and block C, all right. So it doesn't matter if you want to call it tube blocks, buffer piers, or end seal, it doesn't matter, all right. Or, all right, to make things easier, you can actually call it, block A, block B, and block C. Of course, this is a block lah, all right. This consists of many blocks, all right. Now, as engineer, okay, if we are the engineer, of course, we would want, the contractor, all right, to build this. Of course, the contractor require information such as what is the height, what is the width, what is the space between these blocks, and how many blocks you want to have it for this sealing basin. Similarly, for block B, and of course, block C, you only need one block. You don't need to provide the quantity of block, but you need to provide the height as well as the width, right? Okay, and then what else? And then you also need, all right, to let you as the designer, you want them to know what is the distance between block A and block B, and what will be this distance between block B and block C. All right. Sometimes we'll just provide the distance between block A and block B, and it will provide the length between A and C. Basically, the length of the sealing basin lah. Okay. Once you provide the length of sealing basin and you know this space, all right, the distance between A and B, you easily can know what is the distance between B and C already. All right. Now let's look at how you know, what are the notation or symbols used, all right, for the dimension of all these blocks. So we have three sets of blocks here for sealing basin type 3. The chute blocks, buffle piers, and end seal, or you can, you can call it block A, B, and C. For block A, the width, all right, or the basically the thickness, all right, of block A, each of the block A is actually uniform. All these are standard, the same size. The symbol we use for the width is W1 because it's the first block, right? It's easy, W stands for width. What about the height? Is H1. What about the spacing between each block is S1. So it's easily, you can easily remember the notation, because it actually stands for the dimension itself, the characteristics itself. That means the space, the width, and the height. Okay, now probably when you want to design the sealing basin, the first thing you want to know what would be the width of the basin itself, all right, or the length of the sealing basin itself, all right. So the sealing basin itself, all right, the length is denoted by L. If you look at here, it's L, all right. Then, of course, once you have the L ready, you cannot use L ready. So, the next, you have the set of number 1 here. Then, the length of between number 1 and 3 would be L2. Then, for block B, if you look at here, we are using the subscript of 3. All right, that represents thickness. All right. T3, thickness of block B. W3 would be the width of your buffle piers of block B. S would be the space between blocks B. H3 would be the height of block B. And Z3 would be the slope. Okay, this is facing here. Okay, now, of course, this is vertical. Then you have a sloping face here. All right. And C, or the end seal, you only have to find the width. Basically, the width of the channel. You don't need to provide the number, okay, but you need to have the height, okay. There's actually thickness as well, all right. I'll show you the formula later, and also the slope, which is denoted as Z4 lah. By now you should know, the Z would be the horizontal scale, all right, horizontal scale of this. Is the horizontal scale, is the horizontal scale of the side slope, right? Okay, now, so far, anyone has any question? Nurul Halawati, do you have any question?
No, doctor.
Okay, great. So I'll proceed. Okay, then now, this diagram I explained earlier, all right, in the earlier slide. Okay, let me ask you, how are we going to determine the number of blocks? We know the width. Now let's assume, the spillway to have a rectangular cross section. Okay, so you have a width here, all right. This is the width. This is your spillway. This is your spillway. This would be the width of your spillway. Now, if you want to determine the number of blocks, of course we need the width we divide it by the width of one block and the space. So we would know how many block A that we can put in within this width of the channel. So look at this formula here. Number of blocks A would be B is the width of the spillway divided by space and width of one block. Therefore, we will know how many blocks we can fit in within this width here. Alright, so this would be block A, number of block A, and similar formula we are using to calculate the number of block B. So we have B divided by S3 plus W3, it will give us the number of or quantity of block B. Alright, so of course you don't need to calculate lah for block C. There's only one. Now here, this is the table that summarizes all this formula, except I didn't give you this formula, but to get full marks, you need to give me number of blocks as well. Now, another thing, to get full marks, you need to write out H1 equals to S1 equals to W1 equals to Y1. If you just give me Y1, I don't know what is my H1, S1, W1. You are the designer. You are giving information to the builder. If you just give Y1, how are the builder going to build these blocks, right? So as a designer, you need to give them, you at least have to write, if you don't want to write each of them, that means if you don't want to write H1 equals to Y1, S1 equals to Y1, what you can do is you can write H1 equals to S1 equals to W1 equals to Y1. Then we will know that, okay, H1 is Y1, S1 is Y1, and so on, right? Okay, make sure you write it out. If you just give me the value of Y1 is incomplete, all right? You are the engineer, of course you know, all right? But the builder doesn't have this formula, they don't know. Alright. Now, for block B, alright, as I told you when we begin chapter 5, right, the analysis involved, is more of a simple analysis, alright, where you have formulas and we analyze all the data provided. We apply the formula and basically we can obtain the desired design lah. Alright, as if you remember, the formula that we use to calculate discharge over wear and then discharge through sluice gate is quite simple analysis. Involves simple analysis. Now, similarly for these two, this is the design. Alright, but all these are provided, so it's kind of straightforward design. Alright, of course, you initially have to analyze to get the depth of flow on the spillway. Alright, Y1 is on the spillway, and then Y2 is after the steaming basin. Alright, so fruit 1 is based on Y1. Alright, so now fruit 1, once you have fruit 1 and Y1, you actually can calculate the height of block B. Alright, then once you have H3, S3 and W3 is the same, which is 0.75 of H3. You can actually, I don't mind once you calculate S3, you just write W3 is equal to S3 is equal to the value. Alright, I don't mind you want to do that. So T3, right, the thickness, alright, T3, the thickness of block B would be 0.2 H3. Okay, and Z3, this is constant, it's fixed. Initially I asked you, Z3 and Z4 are fixed. You just provide me Z3 equals to 1. You need to provide this. Don't assume that, the builder knows about the slope is to be 1 and this is to be 1 to 2, all right? If you still remember your cut slope, right, it's 1 to 2 as well, in the Jakarta standard lah, basically, all right. Okay, now, so far, I've described, how we are going to design for block P. Now, let's look at this end cell here, which is also known as block C. Now, the height H4 is fruit number divided by 18 plus 1 times Y1, and Z4 would be 2. Here's the thing, if you get your Y1 incorrect, all the answer would be incorrect. So be careful, alright? To finish it up, you need to give me number of blocks A and B, because if I'm the builder, I need to know how many blocks I need to place, right? Then, what would be my L? Alright, the length of my ceiling basin is based on the chart. We'll look at the chart later. This is just to calculate Y1 if Y1 is not given, but if Q and Q is provided and V, you can calculate V lah. Alright. Now, L2 will be based on Y2, which is 0.8 times Y2. By now, you should know Y2 will be the depth after hydraulic jump, because you have high velocity flow that come down. Now, and then after this, you have low velocity or low energy flow that goes out. So there definitely would be hydraulic jump, because you know that when a flow loses energy, right, there would be hydraulic jump that occurs, all right? So therefore, you have Y1 and Y2 after hydraulic jump. So I hope by now you should know where you can get your Y2 using the conjugate depth equation. I hope you still remember that, all right? Okay, now let's look at how are we going to get L from the chart. L is the length of your ceiling basin. All right, this is B. Now, this is our spillway. Okay. This is the hydraulic jump. Our Y1 is after the jump, all right? This is our H1. Remember here, this is your H1. Don't get confused with your H1 on the within the topics of weir that we have learned. In that weir topic, right, flow over sharp crested weir, our H1 is up here, but here we are using H0 here, all right, instead, and H1 here. So the formula would be to find V1. If velocity on the spillway is not provided, whereas if H0 and H1 is provided, you would use this formula here, all right? This is basically the formula of square root 2GH lah. Alright, now which H we are using is H1 minus H0 divided by 2 lah. Alright, so this would be actually this is the free fall velocity. This is the conjugate that equation where you can get your Y2 once you know your Y1. Now, how are you going to get your Y1? You have this formula, formula here. Okay, let's look at this. I hope you still remember this formula here. That you have Y. Okay, let's go back. You have Q equals to AV. Alright. Since I said let's assume our spillway to be rectangular. Our Q would be, now this would be flow on a spillway. So I put Y1 V1. Alright. So how are we going to get Y1 is Q divided by P divided by V1. Alright. So do you still remember that this is also our discharge over unit width? So, alright. Okay, it all comes back, eh? This is what we have learned in our chapter 3 as well, this formula. Alright. So I hope that clears up. Alright. Okay, let's go back here. Okay then. Um. Alright. Okay. Now, once you have calculated your fruit one, okay, based on velocity one, which is on your spillway, right? Okay. Once you have that, now this data comes from experimental data for Stirling Basin type 3. Alright. Of course, if you want to go into detail on the, condition of the experiment, you might want to search, you can go to the USBR. You can search USBR Stirling Basin type 3. They have papers written, alright, that will describe the experiment for you, especially the condition of the experiment. Alright, now once you have this data, draw a straight line. Once it intersect with your solid line, you can draw a horizontal line where you can actually get the value of L over Y2. Now your Y2, you can get it from conjugate depth equations. Once you have Y2, you can easily get L. Alright? I hope, don't worry, we have an exercise later. You can actually go through this later. Um, okay. Now, these are the steps. Here, bear in mind, I provide these steps for you to help you in if you are used to doing the exercise or activity. If you have done it few times, you probably don't need to memorize or remember this step because it comes naturally to you, right? So first thing, because if you want to find length of basin, you need y2, you need fruit 1, you need y1, you need v1, right? So you need to find this out. Probably these data are provided already in the question. If not, you need to calculate. You need to determine all this, alright? Then you find L, alright, from the chart. Now, some of you may ask me, what if the chart is not provided in test or your exam, right? I would say you probably want to write a statement. There is no chart provided, therefore L is not estimated in this question. We just write out. I totally could understand. All right. Why you didn't provide the length of your sailing basin. Okay. There are things that because eventually when we go out as engineer, we'll be independent. We'll decide, we'll make decision on some of the things. So you need to write it out, all right? Now, step 3 would be to design for blocks A, all right? So you have to determine all this lah, all right? Now, that table will be provided. This table will be provided, okay? Except for this, I'm not sure, but this is easily remember, I'll let you know if this is provided or not later, right? But this is definitely provided to you, so you don't have to worry about that much, all right? So, but of course, you need to know how to utilize all those equations. Now, step 4 would involve, designing for block B. And remember here, you need to determine L2. It's straightforward. It's 0.8 Y2. You don't need a chart, so you can actually calculate L2 for me. That means L2 is the spacing between block A and B. It's the length between block A and B. And then finally, you design for the end seal. You need to give me Z4 as well, as well as H4. Sometimes we'll give you T3 or T4. Alright, sorry, maybe T4, which is the thickness for the end seal here. Here we are not providing you, but I guess in the table that will be provided, we might provide you T4, all right? So you need to give us, all right, the value of T4 as well. Don't worry, it's straightforward, eh? Okay. Now, let's look at this one activity. Maybe I'll show the video later, right? We'll just go through our slide first. Activity 5.9 here. We have a weir, 8 meter, all right, on top of this spillway lah, all right, that will release the water. So when I say 8 meter wide, that means the spillway is 8 meter wide as well, all right. So B is 8 meter. Discharging 80 meter cube over second. This is the uppercase Q, is the rate of flow. It's not the discharge over unit width. You have to be careful uh, with the unit as well. So you have Q80, Qmax. H1 is 30, H0 is 5. Of course, you can calculate V1 already, which is 2 square root 2G H1 minus half of H0. Then you'll get V1. All right, design. This is how the question looks like. Design and USBR swimming basin type 3 downstream of the spillway. That means at the toe of this spillway here. So you can actually calculate Y2 already once you have fruit 1. Basically, fruit 1, once you have velocity, once you have Y1, okay, you can straight away calculate fruit number up on the spillway already. Therefore, you can determine Y2. Alright, so V1 is 23. I'll just go through, you should try it out later yourself. Y1 is this. I don't mind, this is your discharge over unit width, 80 over 8, so your Q discharge over unit width is 10, 10 divided by 23.23 is 0.4305 meter. Fruit V over square root GY is supposed to be V over square root GD. I hope you still remember, you are using Y because you assume this to be a rectangular section. Therefore, your D is Y. It comes up to Y, because your T is basically B. Alright. So your fruit number is 11.3. Alright. Of course, just now in earlier slide we have mentioned that USBR steering basin is suitable for fruit number from between 4.5 and about 17. Alright. Y2 using conjugate depth equation. Alright, you have solved with 6.668. Now, one thing that you have to know is you have to know Y2 is definitely greater than Y1 because you would know that the flow of Y2 is has less energy than flow of Y1, all right? And the fruit number, but we don't need to find fruit number for Y2 lah. It should be less than 1 because it's subcritical. Fruit number for Y1, it should be greater than 1 because it's supercritical. Alright. Now, determine length of basin. Alright. L. From chart, length of jump on horizontal flow, L. Now, this one you need to do it yourself because I read it from the chart. L from the chart, when I read it, L over Y2 is 2.75. Therefore, L is 2.75 times Y2. It will give me 18.34. Now, how are you going to read your L over Y2? You need to find out fruit 1 and Y2. Do I have a chart here? No? Okay. If I don't have the chart, let's go back here. Okay, once you have fruit 1, okay, fruit 1. Fruit 1 is, fruit number at upstream is 11.3. So 11.3, this is 2 on the scale of interval of 2, fruit number So 11 point something is here. You draw a vertical line and then you draw, once it cross or intersect with this solid line, you draw a horizontal line and you read it from on your L over Y2 axis is about 2.75. So L over Y2 is 2.75. So L is 2.75 times Y2. Alright, so therefore you have this guy here. And then you can begin to design your block A, B, and C already. So once you have your L, you know the length of your basin already. Alright, it's about 18.34 meter. So here's the thing. I want you to specify what is H1, S1, W1. Write it out. As I told you, alright, I don't mind if you want to write it like this. H1 equals to W1 equals to S1 equals to Y1 equals to what is the value. Write it out, Okay, I don't mind if you want to write it like this. Okay. Alright then, let's go back to our slide. Okay. Equals to 0.43, 0.5. Okay then. So another thing that you need to determine would be to completely design block A, you need to provide the builder with how many blocks they need to build along the width of the ceiling basin. Okay, is the width of the channel or the width of the ceiling basin divided by the space plus the width of one block. Okay, therefore 8 divided by 0.3, so it's about 9, or you can give me 10 blocks. It doesn't matter because we actually have an extra space there. Alright, it doesn't matter. So give me a round number. Alright, you should round it up because if you are going to build a 9.3 blocks, how are you going to build another 0.391 blocks, right? So it must be a round number. Alright, okay. Then block B. Okay, similarly, you utilize all the equations, right? The length, that means the length between block A and B is 0.8y2. Okay, you have there find 5.334. So therefore, once you have L2, you already know between block B and block C what would be the length, right? Because you already have L. Okay, now H3 is therefore using the formula, right? You have about 1 meter height. S3 is about 1 meter high. That means you can guess how high it is. How huge is the spillway? We are about 1.5, 1.6 meter tall. This is like half of us already. No, sorry, a third. Okay. Sorry, two-third of us. Two-third. Okay. It's about two-third of us. So S3 is 0.75, 1.088, 0.75 times 1.088 is therefore 0.816. So W3 is the same as S3. You can write W3 equals to S3 equals to 0.18160. I don't mind. The thickness, okay, is 0.2 H3. Okay. Z3, have to write it out even though it's provided in the table. I want you to write it out because you are designing for the builder. I don't think so you want to provide the box, the table of formula to the builder, right? Because you need to provide the detail for them, because at the end you probably need to provide the drawings with all these dimension, right? Okay, number of block is B divided by the addition of the space and width of one block. Therefore, you can give 5 blocks lah. Alright, approximately 5 blocks. Finally, the design for block C. All right. So the height of block C would be 0.7 utilizing the equation. And then the side slope for block C is 2. All right. Okay, try this out. So I should be sharing slide for chapter 4 and chapter 5 with all the solution by today or tomorrow. Remind me if I haven't, all right? Share it with you. So that ends our chapter 5. Assignment for chapter 5. Assignment for chapter 4 is due today because I already given you 1 week. Assignment for chapter 5 which I have uploaded because I have uploaded all the assignment because I'm worried I forgot to upload them. So it makes my life a bit easier, but I'm not expecting you to submit all your assignment at once because my concept would be once we have finished a chapter, that assignment for that particular chapter would have about 1 week time for you to complete the assignment lah. And then you have 1 week time to submit it through the author. So the due date for this assignment for chapter 5 would be next Thursday, alright? Okay then, that is all for our assignment 5, chapter 5. Do you have any questions so far? Guys, do you have any question?
Tak ada, Doktor.
Tak ada Okay. Kalau tak ada, kita sambung. We will continue next Monday with chapter 6. Alright? Our final chapter.
Okay, Doctor.
Alright.
Okay, Doktor.
Doktor, terima kasih.
Bye-bye.
Thank you, Doktor.
Okay, Doctor.
Bye,
Bye-bye.
Doktor.
Bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doktor.
You're welcome.
Thank you, Doctor.